Welcome once again, everyone, for this third day out of the online 6 days faculty development program sponsored by Atal on innovating agri-tech for a sustainable tomorrow, aligning with SDG goals. Just to have a brief recap, this is the third day. In last 2 days, we have heard sessions from Mr. Sujit Hukkerikar, who spoke on smart agriculture, followed followed by yesterday's, we had two interesting sessions by Dr. Ramappa, who spoke on SDGs contribution in the form of in the domain of agri-tech. Then followed by session by Dr. Shiv Shankar, who gave an insightful session on agriculture practices and SDGs. To continue and to add more light to this session, today we have amongst us Dr. Raviraj M. Kulkarni, who would be delivering a session on nanotechnology and smart agriculture. So we welcome you, sir.
Thank you, sir.
Yes. To formally welcome Dr. Raviraj M. Kulkarni, professor. He is a professor and head Department of Chemistry, coordinator Center for Nanoscience and Nanotechnology, and coordinator BSc Honors Program for KLS Gokte Institute of Technology, Belgavi. He is also the chairman, Board of Studies, Nanotechnology. Uh, Sir did his PhD from Karnataka University, Dharwad, that is KOD, in January 2003, and postdoctoral research work in University of Leuven, Belgium, University of Alberta, Canada, and TIFR Mumbai during 2003-2007. His contribution in the field of nanotechnology is outstanding. 25 years of teaching and research experience stands to his credit. Dr. Kulkarni has successfully guided 5 PhD students and 80 B and MTech final year projects students. Dr. Kulkarni has also published 159 research papers in prestigious national and international scientific journals and edited a book on nanomaterial modified electrodes design and applications in which is published by Springer. He has 2,670 citations for his papers and his H index is 28. Sir has delivered more than 100 invited talks in national and international conference and seminars. He has received prestigious Young Scientist Award for the year 2015 and 16 from VGST Government of Karnataka, and he has also received award for research publications from Government of Karnataka. Winning grants from many funding agencies at the state and national levels, he has completed many research projects. Sir has organized many national and international conferences as convener, established Center for Excellence in Nanoscience and Nanotechnology at KLS Gokte Institute of Technology, Belgavi, to provide a platform to young researchers of GIT to carry out research in the field of nanotechnology. Sir was invited by Synod College and Basin Development Authority of Government of Meghalaya as an expert for water resource management and treatment. Sir is a scientific advisor to Glutrack Private Limited, who are into development of devices for non-invasive glucose detection. Dr. Raviraj Kulkarni also served as an external examiner for University Putra Malaysia and King Abdulaziz University, Saudi Arabia. He is nominated as Chairman Board of Studies of VTU Belgavi. He is a member of Expert Committee of VTU for revamping for first year syllabus 2022-23, constituted by Professor Vijay Shankar, Vice Chancellor of VTU. He is also a member of many professional bodies like American Chemical Society, Indian Council of Chemists, ISTE, IAAM, and many more. He is also in the editorial advisory boards of many reputed journals. With this vast experience, I'm sure that all the participants are going to get the maximum benefit out of this. With this vast, uh, versatile personality amongst us, I'm sure that the sessions will add more value towards this 6 days online FDP. So welcome, sir, and over to you.
Thank you, Ajay sir, for that wonderful introduction.
Thank you, sir.
Shall I share the PPTs right now? PPT right now?
Yes, sir. Yes, sir. You can.
Is my screen visible, sir?
Yes, sir. Your presentation is visible, sir.
Yeah. Very good evening to one and all who are part of this FGP. Yeah, my name is Dr. Kulkarni, and I'm basically a nanotechnology person. And I have done little work in agriculture, not much, but I would like to talk more on nanotechnology and how it is useful in agriculture. Okay. I belong to KLS Gopte Institute of Technology, Belagavi. And let me tell you what is the history of nanotechnology. Nanotechnology is not a new field, actually. Nanotechnology, we have been using this technology since long, in ancient times. But it was introduced by a physicist. His name is Richard Feynman. In the year 1959, he delivered a wonderful talk on on physics. Actually, he's a physicist. Okay, there is a plenty of room at the bottom. Okay, he mentioned about nanoparticles, a very small particles, right? So we have been using nanotechnology from our ancient time. A paper in by German scientist Daniel Butet. He mentions about nanotechnology has been used in bhasmas and all in earlier centuries. Okay, so vibhuti or bhasma is the what we know. What Westerners say nanotechnology, we say vibhuti or bhasma. Bhasma is the first nanoparticle, what we say. Okay, so how bhasma is prepared, we know all these things. It contains, a small amount of silver nanoparticles. Okay, so we used to apply earlier. Nowadays, nobody applies, but in earlier days, it was not a religious thing at that time. It was 2000 years, 3000 years ago. So they used to apply bhasma just to protect their brains and that protect their organs, right? Especially the sensory organs. And how it protects, the bhasma contains, nanoparticles like metal oxide nanoparticles and silver oxide will be there, and they use the ghee, especially the which acts as a lipid. Okay, so it can cross the blood brain barrier as well. If somebody is suffering from tumor, what is the solution? Surgery. If you go to doctor, if you have brain tumor or something, surgery is the only option. In those days, they used to prevent it by using the silver nanoparticles. Okay, if in those days, if you tell it's good for your health and all those things, people will not accept it easily. That's the reason they introduced this religion and all those things into picture, right? So that's how it started. Okay, and there are papers. I'm not saying this. There are papers on this, right? There is one word. Okay, in Austrian Museum. Okay, uh, it's double-edged sword. It's called Damascus word. Damascus is the capital city of Syria. Okay, now it's a war-torn country. In those days, also there was to be wars. Okay, everyone wanted to capture, Jerusalem. Okay, and they were, I mean, they have to cross the Syria. So they faced this word. Okay, this word they used nanotechnology in those days. Double-edged sword. Okay, somehow they incorporated carbon nanotubes in the sword. Okay, carbon. I'll tell you one thing. Carbon nanotubes, graphene. Okay, graphite. Okay, we use pencils. That inside what we see is graphite. If you take a sellotape or Tixo, okay, if you apply it and just rip it off, so you get a single layer of graphite. That is called graphene, which is the hardest material. Of course, graphene is there, but now still we consider graphene is the hardest material, which is 6 times harder than diamond. And these people somehow introduced this graphene or carbon nanotubes into sword. And that sword is a double-edged sword, and I mean, it's harder than diamond. And if these people go with war, I mean, go for war with this kind of swords, the enemy sword is like basically a steel sword. Okay, it not only kills that enemy, it cuts the sword itself. Okay, and there was a research on this. Okay, later they realized this word was developed in India. Okay, it's made up of wood steel. Okay, crucible steel. And Professor Peter Puffler, The name of scientist, German scientist, who wrote an article in Nature. Okay, it's one of the very high impact journal, the Nature. It was published in 2006. He mentioned that this word is from India. It was imported from India because the Arabian Peninsula or something, there was no, ores, especially the iron ores. Okay, they used to import everything from us. Okay, so that's the one of the history, okay, of nanotechnology. Afterwards the guns started, people stopped using this swords. So what I'm presenting now today, I'll just give the brief introduction about nanotechnology and what are the challenges in agriculture and key SDGs addressed by nanotechnology and a brief conclusion. Okay. Uh, so nanotechnology is basically research based. So there are three types of research. One is discovery research, second is invention, and third is innovation. So what is discovery? Discovery means there is something that is already there in the nature and we are discovering it. For example, Marie Curie discovered radium, or a scientist discovered a new planet. New planet is there in the nature. That radium is there in the nature and we are discovering it. Okay, it's pure scientific research, which we are discovering the existing one. And for example, if you go to marriage parties, okay, one of your friend starts singing. You never heard him or her singing, and today you have observed that he is singing. What you have done? You have discovered singer in him. He was a singer, but you didn't know. So that is there in the nature, and you have discovered it. Okay, that is discovery research. What is invention then? Invention, basically, you are inventing something from the known things. Like Wright brothers invented aeroplane. The aeroplane was not there earlier, so Wright brothers invented it. That is invention. Using known things, they assembled known things and they developed. In the first time they developed an aeroplane. When you develop first time, it is called invention, and you improve it. Okay, so now jets are there, right? Now it is innovation. Delta X improvement, small improvement in the invention, we call it as innovation. So I hope this three, okay, we use all the three in nanotechnology. So it's research based technology. So what are nanomaterials? The word nano is a Greek prefix meaning dwarf. Dwarf means something extremely small. And 1 nanometer is 1 billionth of a meter, 10 raised to minus 9 meters. And according to IUPAC, International Union for Pure and Applied Chemistry, that nanomaterials are defined as materials having sizes of the range 1 to 100 nanometers. You can ask me a question here. Why 1 to 100 nanometer particles are called nanoparticles? Why not 200 nanometer particles are also called nanoparticles? Okay, I'll come to that point soon. Nanomaterials show different properties compared to their bulk counterparts. Nanomaterials, they show different properties compared to their bulk counterparts. Okay, for example, nano gold is yellow. Bulk gold is yellow. Nano gold has got different colors. Okay, why they change the properties? How small is nano? I'll come to that point first. Right. A nanoparticle, for example, watermelon, you have seen it's of 10 centimeter radius or something, you can say. Coin of centimeter, 1 centimeter, small coin. A full stop is 1 mm. Okay. If you a single hair, okay, is of 10 is to minus 4 meter. Okay, that's 100 micrometer. Okay, and bacteria cells 10 is to minus 5 meters. Okay, um, right. Viruses like 100 nanometers, gold nanoparticles 10 nanometers or less, and benzene is zero point 0.5 nanometer. Carbon nanotubes, the diameter is 5 nanometer. Water molecule is zero point 0.1 nanometer. Okay, and just giving the size. Okay, nanoscale. Okay, so if you take a single hair, Okay, human hair, it is 100 micrometer. You have to make 100 slices to get 1 micrometer. Okay, again you have to make 1000 slices in 1 micrometer, you get 1 nanometer. That is the size of nanoparticles what we are talking about. So why the properties? Again, I'll come to that point, because why 1 to 100 nanometer particles are called nanoparticles, right? So why properties change? Because the properties change. Okay, from bulk to nano, the properties change because of some effects. Okay, quantum effect or surface area to volume ratio increases, reduction in solid state defects increase. Right, it reduces. Surface to interface forces become dominant, like van der Waals forces and all small forces. They become dominant. 10 nanometer, 20 nanometer forces, they become dominant at that scale. Right, because of these properties, they change when the size is less than 100 nanometers. Okay, so whatever the Newtonian laws, okay, for which are applicable to macromolecules, bigger particles, they are not applicable here. Laws of motion, we say, okay, everybody continues to be in the state of rest or of uniform motion. In physics, we talk about all the laws of Newtons and other things. They are not applicable here. Okay, because of these effects. What are the effects? Electron confinement, greater surface area to volume ratio, reduction in solid state defects, surface and interface forces become dominant. Okay. So one right confinement effect I can explain to you. Okay. You imagine a box. Okay. A cube. Okay. So this is a cube. Imagine this is a 3 meter by 3 meter, or 3 centimeter by 3 centimeter cube. Okay, take it 3 meter by 3 meter. Calculation becomes easier for me, right? So imagine this is a big cube, 3 meter by 3 meter cube. What is the surface area of this cube? Is 6, right, into 3 square. Okay, 3 is the surface area. 6 faces are there, so 6 into 3 square. Okay, I'll come to that again. Okay, why the properties change? So in three-dimensional object, this is a three-dimensional object. Okay, electron can move in x direction, y direction, even in z direction, all the three directions. So it is electron is free to move. Now, if imagine I have a cutter, I'll cut the top edge. I'll cut this. What I'll get? I'll get a sheet. Okay. Now electron is confined. Imagine the thickness is in nanometer scale. Now what happened? So electron can move in only x direction and y direction. Z direction is confined. So electron cannot move in z direction. So because of the confinement, the properties change again. And imagine I have a right scissors. Okay, I'll cut this edge. Now what I'll get? I'll get a string or wire. Now it is one dimensional. Electron can move in only x direction, positive x direction or negative x direction. Now I'll cut this edge, leaving all the dimensions at nanoscale. So it is a nanoparticle. We call it a zero-dimensional particle. Right? Because of confinement, the properties change. Because you are confining the electrons. Okay, conductors become insulators at that scale. This is called electron confinement effect in nanotechnology. I'll give one analogy for this. Imagine there is a line just outside IMER. Okay, though you are virtually present. Okay, imagine there is a line near IMER, and I request everyone to go and feed that line, and that line has not taken food from last night. So we don't go there, right? What is the property of that area? Everyone is afraid, right? Then if we case that line, I'll ask that forest people to come and case that line. Now, what is the property? Nobody is afraid of that line now. No fear. The properties change if you confine the electron also. Imagine instead of line, it is electron. So confinement, so the properties change. Okay. So right. So we have Nano Club at GIT. So we do a lot of such small activities. Now the second one is surface area to volume ratio. Surface area to volume ratio increases like anything. Right. I'll ask you a question here. I'll give you 2 spoons of powdered sugar. 2 spoons of powdered sugar to one group of people, and 2 spoons of crystal sugar to another group of people. The same spoon, the volume is same. I have given 2 spoons of crystal sugar to one group of people, and I have given 2 spoons of powdered sugar to another group of people, and I have given 1 teaspoon of the tea leaves, okay, to both the groups. Now I request them to prepare tea, okay, and now tell me which tea is more sweeter, the sugar, powdered sugar, or the crystal sugar? Yeah, anybody you can interact. Okay. Yes, anyone? Okay. Anyway, if I given you crystal sugar, what will happen? When you powder it, it becomes 4 or 5 spoons. You got it. So you go to flour mill, Girani. Okay, you usually take half box full of grains, but after grinding, it becomes full because surface area to volume ratio increases. Powdered sugar requires more volume. Okay, that if I give only two teaspoons, it will not be that sweet. You need 4 or 5 teaspoons of powdered sugar to match the sweetness of the crystal sugar. Hope you are understanding what happens. The when you powder it, when you go to nanoscale, you require 4 or 5 boxes. One box of grain requires 4 or 5 boxes of, right, powder, the nano powder. Okay, so I'll give the surface area to volume ratio. You can understand this. In the first case, okay, the sides, okay, 3 by 3 is it is, okay, a 3 meter side. Okay, so surface area is 3 square into 6 faces. A cube has 6 faces. Total is 54 meter square. I have not written meter square. It's understood. Volume is 3 meter cube. Okay, 27. So when you take the ratio, surface area to volume ratio, it is 54 by 27. It is 2. Okay. Similarly, if I take 2 by 2, okay, 2 meter by 2 meter by 2 meter cube. Okay. So faces are 6. Okay. So surface area is 2 square into 6, that is 24 meter square. Volume is 2 meter cube. Okay, that is 8. 24 by 8, it is 3. Surface area to volume ratio increase now. Till I'll go down 1 meter by 1 meter box, 1 meter by 1 meter by 1 meter. Okay, sides are 1 meter. So surface area is 1 meter square into 6 faces. So 6 meter square. Volume is 1 meter cube. 6 by 1 is 6 per meter. Now I'll go on breaking this till I reach 1 nanometer by 1 nanometer by 1 nanometer. Okay, nanometer cube. Now what happens to surface area to volume ratio? Surface area becomes 1 nanometer square into 6. That is 1 nanometer is 10 raised to minus 9. So 10 raised to 9, it becomes 10 raised to 18, minus 18. Okay, and volume 10 raised to minus 9 cube, 10 raised to minus 27. So when I take it to the numerator, 10 raised to minus 27 becomes plus 27. So it is 6 into 10 raised to 9. So surface area to volume ratio becomes 1 billion times. 1 billion times. So huge surface area. If you give me a gram of gold, I can coat entire football ground or cricket ground with one gram of gold. I can convert into right nanoparticles and I can coat it. Okay, that is the beauty of nanotechnology. So I just mentioned this. Floor needs larger area compared to grains because of surface area to volume ratio increases. Okay, so why smartphone battery needs recharging every day? Okay, sometimes we use mobile phones. Okay, every day we need to recharge. Okay, earlier, there are small, right, only for calling we have mobiles. Okay, we recharge it once in 15 days, right? Can we recharge this mobile phone once a year? Yes, it is possible using nanotechnology. The next nanotechnology we talk about this, right, increasing charge capacity. So global lithium battery industry is huge. Okay, it's another field in nanotechnology. Okay, because of surface area to volume ratio increases. Can you recharge your mobile within a fraction of a second? Yes, it is possible. Supercapacitors are there now. Okay, supercapacitor, they use nanotechnology. Okay, and its market is growing like anything. Nanosensors. Nanosensors. Okay, the first guy you can see him. He is Ben. His name is Ben Johnson. Okay, when we were kids, we used to watch him running, 100 meters. He was a sprinter. Okay, in 1984 Olympics, I remember he won all gold medals. In 1988 also he won gold medals, but he was caught taking performance enhancement drugs, and they detected it because they developed sensors. So there are different types of sensors: resistive sensors, capacitive sensors, optical sensors, electrochemical sensors. All these sensors we use them in even in agriculture. Okay, for different applications. Right, sensors. Okay, nitric. If you are breathing out nitric oxide, it indicates, for example, 2 ppm is allowed, 4 ppm if you are breathing out, it indicates you are asthmatic. If you are breathing out acetone, okay, it's very difficult to detect with normal sensors. Nanosensors can easily detect. Okay, if you are breathing out acetone in your breath, it is you are diabetic. Okay, police also does alcohol test. Okay, nowadays nanosensors are used. What is the advantage of nanosensors? Because nanoparticles are very small, right? Very, very small. So if any gas particle sits on that, you can easily count it. See, there is a stadium, there are more than 1 lakh people, and somebody is doing some mischief. It's very difficult to identify. But if there are only 10 seats are there, and you can easily identify them. That is the advantage of nanotechnology. Very small space, okay? And if gas molecules or anything, they come and sit, you can easily detect them. So nano sensor market is huge. It's also huge. Okay, it's in trillions. Okay, that's all sensors are used in agriculture. Agriculture is fine. And now I'll just give some information about quantum dot sensitized solar cells. Solar cells, okay, we know like silicon-based solar cells and all. Nowadays they are very costly, right? Silicon-based solar cells. Nowadays we people are talking about the quantum dot sensitized solar cells. Even quantum dot TV television is there. Quantum LED, QLED TVs. Okay, that's everything is based on nanotechnology now. Okay, this nanotech, this I don't want to explain this. This is used in solar cell to convert light energy into electrical energy. Self-cleaning paints. Okay, it's another nanotechnology aspect. Okay, we mimic like lotus leaf. Lotus leaf. Okay, when a water droplet is placed on the lotus leaf, okay, it retains its spherical shape. Why it retains? Because there are hair-like structures on leaf. They are called papillae, and they are coated with wax in lotus leaf. The same we can mimic with nanotechnology, right? For example, zinc oxide nanoparticles. Okay, using polystyrene, zinc oxide polystyrene composite can be made. Zinc oxide, right? You can just take waste batteries. The container itself is zinc. Just put it in some nitric acid, it becomes zinc nitrate. Okay, add urea. Urea is available as a fertilizer. You just mix it and burn it. Okay, so what you get is zinc oxide nanoparticles. And waste, boards, welcome boards and all made up of what is that, thermocol. Thermocol in chemistry terms it is polystyrene. Okay, polystyrene we call, but it is thermocol. So you can dissolve it in toluene. Just put toluene, it will dissolve whole 1 kg in 100 ml, and you just add zinc oxide nanoparticles that you have prepared by burning. Okay, and mix it and coat it on any surface, it becomes super hydrophobic surface. Okay, they're used in waterproofing and all those things. Very simple. Nanotechnology is not that complicated. You have to understand basics, little bit physics and chemistry, but it's useful in very variety of applications. Right. So carbon nanotubes are also used. Okay, self-cleaning paints. Okay, when water droplets falls, it rolls down. It will not stick to the surface. Okay, this is another application in civil engineering. There is a huge market for this also. 171.55 billion. Okay. So gold nanoparticles, gold bulk gold and versus gold nanoparticles. Normal gold is yellow in color, but gold nanoparticles have different colors. Okay, so two nanometer gold has got different color. 5 nanometer gold has got different colors. Okay, uh, purple, pink, no, red, orange, red, every right. As the size increases, the color changes. Okay, higher the size, okay, it's a lower wavelength, that is red color you get. Okay, lower, smaller the particles, you get blue or violet because higher energy, right? So you get different colored. We never imagined that gold has got different colors, but in our ancestors knew it. Okay, next slide shows this one. Okay, Swarna Bindu. Okay, it's in Ayurveda. I collaborate with Ayurvedic people. Okay, you can see the color of gold nanoparticles, Swarna Bindu. It is pink. Okay, so gold nanoparticles have been used in our Indian this one because first time when we feed a baby, we call it as annaprashana. There, what they do is they rub the gold and put it in the this one. So it has got good, I mean, immunity and all for that they use. Okay, the Swarna Bindu. All right, I just wanted to show you the color of the gold nanoparticle. It is pink. It is not yellow anymore, gold anymore. Okay, golden color we say no. Golden color has got different colors. For example, if I coat my this one coat with gold nanoparticles, I have a switch here which regulates the size of nanoparticles. Okay, in future there will be technology. Okay, if I change the voltage, I can make bigger nanoparticles. As size increases, the color changes to red. I can decrease the nanoparticle size, it becomes blue. Okay, the same dress I'm wearing, I can change the color, it will come. Okay, it's a right, definitely a nanotechnology application. Now, okay, I discussed many things about nanotechnology. Okay, of course, I didn't talk about much about surface and interface forces. Of course, they become dominant at nanoscale. I'll just give information about that also. The four property, why the properties change at nanoscale. The third thing is the surface area I have discussed. Okay, and quantum confinement I have discussed. Surface and interface forces. Okay, so van der Waals forces of attraction and all, they are like 10 nanometer per 20 nanometer. Imagine we are playing a cricket match. We are all nanoparticles, nano-sized people, and a bowler is bowling. Okay, there is a de Broglie hypothesis is there. Okay, any particle is associated with wave. Okay, normal bowler runs in macro scale. Okay, in bigger scale he runs, but in nanoscale wave is associated. He will not be just running, he will be jumping up and down, up and down. And the ball he is holding, it will be vibrating with a certain frequency. And when he balls, the batsman is also not stationary, he is also jumping up and down. Right. So because of that, and what happens when the ball is bowled, okay, sometimes the ball may stick to the bat itself, or ball may go somewhere else. There is totally uncertainty. Okay, it's called Heisenberg uncertainty principle. Okay, so these things happen when the size is less than 100 nanometers. Okay, and because of that, van der Waals forces of attraction and all those things, so many things happen. And another thing is like um, defects. There will be less defects at nanoscale. Okay, if I ask you to build a small, blueprint of a house, okay, it's more harder compared to the actually building itself, because there will be less defects. Okay, you arrange only 100 atoms. You can arrange it properly. If I ask you to arrange billions of atoms, it's very difficult to arrange. Okay, there will be defects. Okay, bigger things, bigger all right, objects have got more defects. Schottky defect, Frankel defect, whatever the metal defects we say, they are more in macro scale. Okay, in nanoscale the defects will be less, so they are harder material. For example, copper wire. Copper wire, it is malleable and ductile. Normally, you can make wires, okay, and you can make it a sheet. Okay, malleability and ductility is there. But when it is nano, if less than 50 nanometer, you cannot bend it. It is super hard. Okay, that's what I told. Graphite is very soft, but graphene, single layer of graphene, when you take a sellotape and apply it to the pencil lid and rip it off, okay, that layer, whatever you get, is graphene. Is called graphene. It is super hard material. Okay, right. And when you roll that graphene into like agarbatti bundle in nanoscale, okay, imagine in nanoscale, it's called carbon nanotube. Okay, just give you some brief information about what is carbon nanotube, and I'll be using those terms, right? Now coming to agriculture, okay. So what are the challenges we are facing? Is low crop yields, water scarcity, inefficient irrigation, pests and diseases, okay, soil degradation, poor soil fertility, excessive use of chemical fertilizers and pesticides, food security, and post-harvest losses. Because what happens once the harvest is over, they collect all those things because of some disease. This one they decompose or right, degrade, right, the food materials. The climate change is another problem. Environmental stress is there. Lack of access to resources for small scale farmers. These are the challenges. Okay, low yield, especially in India, it's because we don't use smart technologies most of the time, right? So yield is less because other countries, they use precision farming and all. Okay, they use satellite data and all those things. They analyze the data, and right, we don't do most of the time. Of course, people are studying now, but small scale farmers, right, poor farmers, they don't use all these things. They're just the traditional farming they do, and they use a lot of pesticide. If you ask them to add 1 liter, they'll add 5 liters. Sometimes it is happening. And what happens to these pesticides? They go into the environment. When it rains, everything, it goes to water, river water, and this river water is contaminated. And the same water is supplied to households. So it is there. All kinds of problems are there in Indian agriculture. Food security. This one. All right. Climate change is another issue. Right. This time is more cold or right. All right. There are so many other issues like pests and diseases are the biggest issues. Okay, pesticides and this one we use, and even the fertilizers. Fertilizers also we use a lot. Okay, but nanotechnology has a solution for this. I'll discuss one by one. So nanotechnology solution for challenges. Nano coatings. Fertilizers, conventional fertilizers often result in nutrient leaching. Okay, meaning nutrients are lost in the environment. Right. So usually we use like 50 kg to one right quintal fertilizers per acre. Okay, it's huge, right? But if you use nanotechnology based this one, okay, nano urea and all, they are coming just half a liter to 1 liter. That's sufficient. Okay, you have to spray. What is the advantage of nanotechnology? Because they're so small, the guard cells of plants, leaves. Okay, it can easily go through that. Okay, you don't have to spray at the roots. You can spray on this one, that plant itself. Okay, it absorbs. Right, nanotechnology, because nanoparticles are so small. Okay, and control release, sustain release. Okay, nanotechnology can help to produce control release fertilizers. Control release means you encapsulate the fertilizer with polymeric or any metal oxide nanoparticle. Okay, and inside the right fertilizer is there or pesticide is there. You can just load it and it releases slowly. Okay, when it rains, for example, when the pH goes up and down. Okay, when it rains, pH goes down. Remember, pH of the soil or anything goes down initially because the pH of the water, distilled water, is around 5.5. The rainwater is not 7 pH because carbon dioxide dissolves while falling, while precipitation. Okay, its pH is 5.5, slightly acidic, or 6. Okay, so what happens? You can manipulate. Okay, when to release, when not to release. Okay, based on the pH, it releases based on some stresses. Okay, sometimes because of sunlight, it may shrink and it may release. Okay, they're called smart materials. Okay, encapsulations. Right. This ensures that plants absorb nutrients more efficiently. You don't require right quintals now. You require just 1 liter or half a liter of fertilizer. Okay, even 100 ml or 200 ml of pesticides. That's sufficient. So I mean, you are controlling the losses. Of course, the cost of these materials still are high. You can reduce them, okay, because the new technology, right? So this ensures that plant absorb the nutrients more efficiently, okay, because uptake is more. When we take nanoparticles, the uptake is more, okay. Uh, for instance, nanosilica coated fertilizers can enhance the nutrient uptake by the plants, okay. Nano fertilizer industry is also huge industry, 3 billion in 2022, and it may go up to 9.2 billion in 2030. Okay, CAGR of 14.5% over the forecast period of 2023 to 2030. Okay, so it's already there in the market. IFCO nano urea is there. Okay, reduces input cost, environmental friendly, right? So improves nutritional values, increases farmers income, and because productivity increases, yield increases, and you require very small amount of, the cost of production decreases because you are using very small amount. And if they are environmental friendly materials, nothing, right, they are safe. Okay, so there are some issues with nanotechnology also. I'm not saying that nanotechnology is foolproof. It is, there are some issues because it can enter into your body also. If you spray nano, right, pesticide, okay, right, our pores here, the sweat glands, okay, sweats, whatever this way you that you get is microporous. Okay, nanoparticles can easily enter, but you have to, right, take precautions when you spray all these things. Okay, so right. Now, nanofertilizers in Kenya, one case study is that nanotechnology has been applied to improve the soil quality. Okay, nano encapsulated fertilizers, okay, slowly releasing the nutrient crops, enhance crop yields by 30%. Okay, this increased food production contributed to food security because SDG goals you have to meet, improved income for local farmers like poverty reduction, hunger. Okay, all these things we are addressing with nanotechnology, and people have started implementing in Kenya. They have started implementing even in Dubai. They are, it's purely desert land, okay, desert soil. So they use clays, nano clays. Okay, I'll be discussing that in the coming slide. Okay, local farmers are getting benefited by this kind of nano fertilizers. Smart irrigation systems. Okay, next is you can use hydrogels. Hydrogels means they absorb moisture quickly. Okay, and they retain the water. Okay, nanotechnology has enabled. Okay, you can make nano granules of these nanoparticles. Okay, which are hydrogels, nano hydrogels. We say they can absorb large amount of water, okay, and released into the environment very slowly. I can give you an example of hydrogel. Um, People know in for small kids we use diapers. Okay, the material whatever they use is hydrogel only. Okay, it absorbs. Okay, right. So these nanohydrogels helps in this they help, okay, in maintaining soil moisture and ensures the plant to have steady water supply, reducing need for frequent irrigation. Okay, this is complemented by what we do is sensors. Moisture sensors are there. Okay, if moisture level goes down, it releases something like that. They, right, technology they usually they use cellulose based hydrogels, and and sensors along with this. So nanohydrogels can be used to, right, release water. Okay, to make it the soil should not be dry. That's the reason we use this. Nano sensors for moisture monitoring. Okay, is another thing. Okay, soil moisture sensors. Okay, nanotechnology based sensors. Okay, they may be based on electrochemical sensing or um, capacity sensing, whatever the sensing they use. Okay, it is basically they test the moisture content. These sensors can relay data to farmers, allowing them to irrigate. Okay, if it is dry, then only you can irrigate. Okay, then again the smart gels, hydrogels, the nano hydrogels, they absorb the moisture. Again, they retain the water again. Okay, once they retain the water, don't have to right, irrigate again. Okay, they release slowly, and once the sensors gives you a data, okay, when to irrigate again. Okay, this technology helps in precision agriculture. Okay, optimizing irrigation and conserving water. Because if our farmers, what they do is they just uh, use water like anything. Okay, because what happens, sometimes plants die because of water this one supply, right? So that optimum usage of water is very important. That can be done using nanotechnology. And another problem is the pests. Okay, it's very difficult to control the pests. You do whatever you spray, like anything. If you have, cauliflower, you might have seen. Okay, if you are using cauliflower, the upper layer you see the cauliflower, it is like little bit oily. They use lot of pesticides on that. Okay, so because of that, what will happen? Right, you are using more pesticide and you are contaminating the soil. Right. So to avoid that, you can use nano pesticides. Okay, so here what we do is we use semiochemicals. What are these semi-chemicals? Like pheromones, because these pests, okay, they, how we speak, we communicate by speaking or making some gesture or something, right? Hand gestures, okay, it may be right. What any kind of communication, okay, verbal communication or right, any other communication. But these pests, they use chemicals, they use pheromones, okay, to communicate. And what you have to do is you use that those pheromones, okay, that's called semiochemicals, to lure these pests. And inside the nano, right, there's a carrier, nano box or something. Okay, inside there is a pesticide. You are luring that pest to come and sit on the nanoparticle. When it sits on the nanoparticle, and of course it contains pesticide, it kills that pest. Okay, thus you minimize the use of pesticide, and also it is more effective because you are using pheromones. Definitely they'll come because you are attracting them. Pheromones are used to communicate. Okay, you are telling that there is a something. Okay, the other pests also come and they sit on that surface. And when they sit on the surface, pesticide is there, it kills. Okay, this is one technology, nano encapsulated pesticides. Early diseases. Early diseases now nowadays, you get satellite data and all the sensors are there. Right. So you can easily detect. Okay, even sensors are there in the right on sites. Okay, and blight in potatoes or powdery mildew in wheat. Okay, this can be identified in early stages if you use sensors, nanosensors. Nanosensors, even a small amount of this disease plant, this one, organisms, they grow, pathogens, they grow, they, it immediately detects, and it, right, you can just spray the pesticides or something on that. Okay, you can control them. As I mentioned in the earlier, okay, nanocarbon materials are used. Okay, nano materials such as nanocarbon can be used, which is added to the soil to improve its structure, increase the water retention, and promote the growth of the beneficial soil organisms, microorganisms. Okay, nanocarbon is used. Earlier, in earlier days also we were using ashes and all those things, right, in the farmland. Okay, nowadays I think that organic farming has stopped because we used to ash and this one, right? So that is very important. Okay, uh, nanoclays, nowadays, in Israel and Dubai, they have started using nanoclays. Nanoclays, when you spray it on even arid conditions, okay, the desert condition, it's a desert, right, Dubai and all those things. If you spray the nanoclays, montmorillonite or cavolite or something, if you make it nano, and this increases water holding capacity. If you take soil, it will, if you press it like this, it will fall. Okay, if it is a desert soil. Okay, if you add the clay particles, nano clay particles, with some smart hydrogels in that, okay, it holds that soil. Okay, it retains that water. You can grow. See, people are growing trees in Arab countries using nanoclays. Okay, you can convert a desert land into fertile land using nanotechnology. Yeah. Mm. Soil remediation, another technology. All right, what we do is we use iron oxide nanoparticles. Iron oxide, rust. Okay, it's it's environment friendly. Rust is there. Okay, red soil. If you see, it's iron oxide content. It contains iron oxide. Iron oxide is there in the environment. Okay, if you use that iron oxide particles, nanoparticles, nanoparticles has huge surface area. They can, right, the heavy metals like lead, arsenic. If the soil is contaminated with this, so what it does is it sequesters or immobilizes that contaminant. It holds that when it sits on the surface of iron oxide nanoparticle, lead will stick there, arsenic will stick to that surface. Okay, it will not come out. You can immobilize it. Or if it contains like pesticides and all, when iron oxide nanoparticle is there, for example, if that organic pollutant, that pesticide and all, it sits on that, and when light falls, okay, iron oxide is a semiconductor. Okay, electron hole pairs are generated. It takes electron from the waste, that pesticide, and decomposes the pesticide into carbon dioxide and water, because pesticides are not non-biodegradable. If they are contaminated in soil, it destroys the soil properties, because some organisms are required in soil. Right. These nanoparticles help break down or immobilize toxic compounds, substances in the soil, restoring its fertility, making it safer for agriculture. Okay. So this is soil remediation. And then nanotechnology is also used in smart packaging. Nanocomposite packaging films. Okay. Nano silver. We have been using silver. Okay. Nano silver, as I told, Bhasma. Okay. So it can be small amount of nanoparticles which has got antibacterial property. It kills microbials. Okay, it has got antibacterial property. Earlier, people used to use the silver plates. Okay, small amount of silver enters into your body. Anyway, you are eating on silver, definitely small amount of silver enters into your body. If you are eating on a using a steel plate, definitely steel particles will enter. A small amount in nanoscale, not in macro scale. Definitely, if you are drinking water from plastic bottles, definitely small amount of microplastics will enter your body. So it's like that. Okay, right. Whatever we use, that particles will enter. So nanosilver is used in food packaging to prevent spoilage or contamination. All right. If you coat with like food materials with nanosilver, okay, it will not the bacteria or the microorganisms will not decompose that material, because they will die, because the nano filtration nano silver will kill them. Okay, so this type of packaging can extend the shelf life. You can store the fresh produce like fruits and vegetables for a longer period. Shelf life means how long you can store the fruits and vegetables, reducing the waste. So smart packaging using nanotechnology, nano silver, or any other, there are so many, just I'm giving you nano silver films. Okay, have been shown to inhibit the bacterial growth and keeping food safe for longer period of time. So what we addressed here today is key SDGs. Okay, there are 17 SDGs. Okay, with nanotechnology, at least five can be easily addressed. Okay, so zero hunger, definitely it enhances the crop yields through improved fertilizers, and pest control reduces waste and increases food security. SDG 6 talks about clean water and sanitation. It improves water efficiency, quality using efficiency and quality using nanotechnology in irrigation and water filtration systems. SDG 12, it talks about responsible consumption and production, minimizes resource waste, and optimizes inputs like water, fertilizers, and pesticides, responsible consumption and production. Okay, you are not using a huge quantity, you are using very small quantity of nanomaterials. And SDG 13 talks about climate action. It reduces carbon footprint through the efficient resource use, okay, uh, and sustainable agriculture practices. The SDG 15 talks about life on land, promoting biodiversity and soil health. Healthy soil is crucial for agriculture productivity, and nanotechnology will help to restore and maintain soil health while promoting biodiversity. Right. So we have already discussed all these five SDGs. Okay, which actually 17 are there. Five can be easily addressed. Okay, the others can also be addressed to a minimum levels. Right. So in conclusion, what I tell you is nanotechnology offers solution to a variety of pressing agriculture challenges, from improving crop yields and water use efficiency to in reducing the pesticide reliance and enhancing food security. Through examples like nano-encapsulated fertilizers, smart irrigation systems, and all this, okay, we can provide, right. This is control, this is detection. Okay, nanotechnology is providing farmers with the tools to meet the demands of growing global population while promoting the environmental sustainability. However, as with the new technology, there are careful regulations where government will put some regulations, safety right consideration. As I mentioned, no technology is safe. Okay, so you have to make it safe. So you have to take precautions. As I told, when you are spraying nano fertilizers or nano pesticides, some pesticides or some fertilizers will enter into your body. So you have to cover your body, right, with PPE kits. Okay, uh, right. So that's another challenge is there. I will not say that it's 100% foolproof. Okay, there are some challenges in nanotechnology as well. I can give some examples. Okay, this is up to this is about the agriculture. I give some more examples of nanotechnology applications. Turmeric, we can go for nano turmeric now. Normal turmeric, okay, because our body takes very easily the food which is finely powdered. Okay, because it easily absorbs that. Okay, turmeric, there is a curcumin content. Okay, the color of the curcumin is yellow, but if you add, if you make it alkaline, it is red. Okay, red, the alkaline things the body can easily take up. Okay, because acidic things we don't easily, it will not digest easily. Alkaline things digest easily. That's the reason we use, turmeric. The women apply turmeric. Okay, and they add, what is that, calcium oxide, okay, tuna and all, and they make red and they apply. Okay, because it easily absorbs. Turmeric has got antibacterial property. Okay, so nanotechnology can help them in absorption of this kind of medicinal food. Okay, plants. Water is another problem. Okay, right. So how safe is our drinking water? As I mentioned, agriculture usage and all. We use pesticides and all those things. Okay, farmers spray pesticide like anything into. Right, pesticides are there in the water bodies. So we have to remove those pesticides. So there are some nanofiltration membranes. Okay, and even pharmaceuticals. If you go to doctor, they'll prescribe you some antibiotics. Okay, their antibiotics are like poisons only. Okay, so 80% of antibiotic goes into the environment. So there are emerging contaminants. Okay, I'm not going to discuss on this pharmaceutical pesticide. So we use, right, how they enter, pharmaceuticals enter into the environment. Okay, these are all right. Uh, I'm not going to discuss on this because it's out of scope for this talk. Right, but anyway, because water is used in agriculture, that's why I'm giving you some information about water, what we do. So there is a membrane technology, right? What we do is we use reverse osmosis and nanofiltration membranes. Okay, they are all based on nanotechnology only. Okay, so membrane market is valued 564.81 million in 2021. Now it is poised to 630 million. Okay, in USDs. Okay, CAGR is 8.5% in the forecast period of 2023 to 2030. Okay, so nanofiltration membranes are used to purify the water. So I think you know this lady. She is Nita Ambani, and she's using that. She is holding that bottle that is Aqua di Cristallo Tributo Modigliani. Okay, which the cost of that bottle is around 40 lakh rupees. Okay, so water technology, right? Nanotechnology has a huge potential. You can earn, you can make a brand or something. In the market is this alkaline water, because alkaline water people are now, they are interested in drinking alkaline water because it digests quickly, because acidity problem in Belgium city and these our cities, so people are drinking alkaline water. But alkaline water can be made, okay, with the normal water by adding small amount of calcium bicarbonate or magnesium bicarbonate or potassium bicarbonate, or you can use ash. Just add a gram of ash. Okay, I was invited by the chief minister of Meghalaya as an expert for water treatment. Okay, I visited Meghalaya in 2019, and he's Chief Honorable Chief Minister of Meghalaya, Conrad Sangma, and the other one is Sri Medba Lengdo, Honorable Water Resources Minister. I met them, and we discussed many issues related to water and quality of water. So I received awards from Canada government, and nanotechnology is also used in various other applications like water purification and all. Right. Um, Photocatalysis is another thing. Okay, for purification of water. Right. So I'm not going to in detail. Anyway, I already discussed some things. We can how to make nanoparticles. There are different ways. Okay, one is top-down method, another is bottom approach. Top-down method means you take bigger particle and just hammer it, powder it till it reaches nanoparticle. It is a physical approach that is called mechanical approach. Okay, it's called top-down approach, bulk to nano. Otherwise, what you do, chemical approach you can use from uh, atoms, join them, clusters, and make nanoparticles. Okay, how right? There are two methods: top down and bottom up. And simple combustion technique can be used to make nanoparticles. Okay, so we prepare nanoparticles like just 1 or 2 gram of nanoparticles. Right, when you powder them, it fills up whole beaker, 100 ml beaker. Okay, because their surface area to volume ratio increases like anything. Okay, so I'm not discussing graphene, how we prepare graphene and all. All right, it can be prepared in our laboratories. And this is the, we cannot see nanoparticles because they are very small. Okay, our eyes can see with the with best microscope, we can see up to 250 nanometers or 0.25 microns. Below that, we cannot see. So we have to use electron microscopes. And these are electron microscope images of graphene. Graphene, single layer of graphite. Graphite, if you take single layer of graphite, it looks like this graphene. There are other methods like sol gel method is there. Okay, sol gel method of preparing nanoparticles. Right. So sol is solid dispersed in liquid. Okay, it's called sol. Gel means liquid dispersed in solid. Okay, like your butter, for example, is gel. Okay, more solid, less liquid. Okay, this method we can like simple hydrolysis and condensation we can generate. We can make the nanoparticles, metal oxide nanoparticles. Chemical vapor deposition method is another method of making nanoparticles. Okay, for various like agriculture applications and all. We can do it. Okay, it's a very easy to make nanoparticles. Of course, characterization takes some more time. Okay, chemical vapor deposition technique. Right, we use this nanotechnology in chip making. And finally, I acknowledge all the all my students. The first row is my students, PhD students. They have completed my PhD under my guidance. First one is Dr. M.S. Hanigadkar. He has done PhD in 2015. Second is Dr. Maladi. He has done PhD in 2017. And third person is Dr. Bhamre. He has done PhD in 2019. The fourth one is HOD Mechanical Engineering in GIT. He has done PhD in 2021, I guess. And the person, Dr. Vaibhav Chatting, he has done PhD under my guidance. And Dr. Prasad Puja is in, all are different fields, you know. First three are like chemistry people. The fourth one is mechanical engineer. Fifth is civil engineer. And the last person, Prasad Pujari, is from computer science. So we work on IoT based water quality monitoring. So this is nanotechnology is very diverse, multidisciplinary. Even I'm collaborating with um, MBA people, Dr. Praveen Kulkarni sir. Okay, we are working on that nanotechnology related. And the second row is that Professor Peters, my professor in Belgium. Okay, where I was doing postdoc. And second one is Bart Dills. Okay, he is a scientist at Belgian Institute of Space Aeronomy. The third person is Dr. Eduardo. He's a professor of chemistry from Spain. And the fourth one is Dr. Sean Call. He's from Cambridge. And the fifth, the lady, all right, she was my professor in Canada, UNG. Okay, University of Alberta. She's professor in University of Alberta. Next person is Yunus Shukur. He is a professor of biochemistry. He's my collaborator from Malaysia, University Putra, Malaysia. And the last row, Professor Nandi Beur from the left. Okay, he's my guide, Dr. Anand Deshpande. He is the vice chancellor of Bagalkot University. He is my collaborator. Dr. Ganesh Chate, he is my collaborator. Dr. Praveen Kulkarni is my collaborator. Dr. Nagra Shetty is my collaborator from Kelly Technological University. And the last person is Dr. Amin Bhavi. He is 78-year-old and he's my teacher and my collaborator. And he is the next most cited scientist next to Dr. CNR Rao in India. So I'm collaborating with good people. Um, any questions? I'm ready to take. Thank you for patiently listening.
Yes, so I think in the chat box there are a couple of questions. I think first question you have already
Sir,
addressed
just a
earlier.
second, sir. I just make it
Yeah,
louder a little bit. I'm not able to hear you.
sure.
Yeah, please ask me the question, sir.
Yes, sir. So this is Ajay here. I think
Yeah,
in the
yeah,
chat box there are a couple of questions. I think one of the
yeah.
questions you have already taken through your presentation. That question was: Are nanotechnology coated fertilizer used in cost? Is it cost effective?
Yeah,
And
it is initially any technology. Okay, when the paracetamol tablet, once paracetamol tablet which is used for antipyretic, okay, analgesic tablet, right? So that was like 1 rupees. Now also it is 1 rupee only. Okay, so 30, 40 years, 1 rupee is like huge money at that time. Right. So technology, okay, if as it improves, okay, the cost automatically reduces. Initially, of course, it's costly compared to the conventional. Yes.
there was another one more question: How widely is it being used, and what are the challenges in its adaptation?
How?
Adoption.
Wisely.
How widely is it being used, and what are
Wisely.
the challenges in its adoption?
Now people have started using this. Okay, challenges are there. As I told, challenges will be there because when we are using a technology, okay, nuclear power can be used for good thing, energy generation, okay, and it can be used to destroy things. So similarly, nanotechnology is also like that. Okay, nanotechnology, if you are careful, okay, it can be used. Like people started implementing in Dubai. They are converting the desert land into fertile land using nano clay. This is nanotechnology. Nano clay mixed with hydrogels, nano hydrogels. Right, they are using it. Right, challenges will be there, but definitely the solutions are also there. And people have already using this. They are using already, and definitely it is for Indians. It is definitely useful because already government of India, I think they are giving some subsidies also for this nano urea and all. I guess I'm not that agriculturist, but I know that they are promoting this nano fertilizers because you don't have to use like 100 kgs when you can use 1 liter of nano fertilizer. I hope I answered.
Yes. So there was one more question. Uh, please suggest. There is Professor Dinesh Jain. He says,
Yeah.
please suggest nanotech-based agri opportunities to take up for small-scale businesses.
Oh, definitely. You can make nanoparticles easily. Okay, I just told you zinc oxide nanoparticle can be made. Okay, waste this one you have battery waste. Okay, just connect take that container, battery normal dry cell container is zinc. Just put it in nitric acid or something. It dissolves and it forms zinc nitrate. And urea is a very cheap thing. Okay, just add it, double the amount and burn it. You get zinc oxide nanoparticles. Similarly, you can prepare silica nanoparticles. And when you prepare these silica nanoparticles, you have to characterize. Of course, you need some scientist support. Okay, you can come to me. I can just take down my number. I can just I'll help you to start a business because You can start, right, you can develop gels, okay, nano gels, okay, hydrogels. You can make nanoparticles, nano encapsulations we can do, okay, right, fertilizers or pesticides. And of course that semi-on chemicals, no, that's very difficult to make, okay, those kind of costly things, okay. But definitely nano clays you can make. You can convert a desert land into fertile land. Nano clay definitely can be made. Clay is a natural thing which is available, see, you just in soil, okay. Especially you can I remember the clay, importance, okay. I was visiting one, I did some research on Panchaganga River. Okay, one of my PhD students, she did work on that. Okay, and there are some point sources of pollution where in Ithilkaranji area. Okay, they use a lot of there are a lot of textile in this one, and they release. Of course, they treat it, but some they release directly to the water bodies. The thing is, the water cleans automatically. If you go to next half a kilometer or so, again you can the water is again drinkable water. It's very strange, right? Because the bed has got kevinite or montmorillonite, the clays which absorb, which take this, which absorb all this right contaminants, toxic contaminants. And when right, nature has got its own mechanism. When it rains, right, it is everything is gone to the sea. Okay, during sun, what happens? These materials are absorbed on the clay, and when they are exposed to sunlight, they decompose and they degrade. Again, automatically it cleans up the clay. So clay is a very good thing. Okay, and you can work on clay, and it is very cheap. Okay, it's mud only, from that you can extract the clay. Okay, it's not that costly, and you can convert that into nano clay. Nano clay. Okay, there are procedures, there are processes. Okay, I can help you. If you can write to me, I can give you the procedure.
Yes, sir. Thank you, sir.
Yeah.
So I think there are some participants who would want to ask questions directly.
Yeah.
Pratibha Rai, you can just unmute yourself and you can ask the question.
Sure, sir. Thank you. Thank you so much. And I'm so grateful to the presenter that he's given a very informative session. But I have certain questions, sir. It's your focus has been more on benefits of nanotechnology,
Yeah, I
and
told there are challenges as well.
yes, sir. So
Yeah.
I have a question that, it said, I don't know, this is very new domain for me. The nanoparticles, they are all non-biodegradable and non-disposal. This disposed of
No,
material
no,
might
no,
form a
no.
new class of biodegradable pollutants. And then we say that, if they're used in large enough volumes with standard quality and at an acceptable cost. So we have to be very careful with the use of this. Is it a myth or it is true?
No, you talked about what kind of nanoparticles, madam? You just talked about
I mean,
uh,
very
poly.
generic. I'm talking about, it is
Ha.
uh,
So
very
for
generic
us,
statement that I'm
yes,
making.
yes,
Yes.
yes. I got it, madam.
Yeah.
Yes, this whatever we are talking, we are, for example, cellulose, nano cellulose, for example.
Yes.
Nano cellulose, we wear cellulose, cotton,
Yeah.
cellulose. It is there.
Yeah.
It is biodegradable.
Yeah.
Plant, no, bark of a tree
Mm-hmm.
is cellulose. It is biodegradable.
Mm-hmm.
Yeah, you can make nanoparticle out of it. It is biodegradable. Polylactic acid based things, they are biodegradable.
Mm-hmm.
Starch, biodegradable. Nanoparticles, over the period of time they decompose. Of course, again you have to spray it again. But clay and all, they are required. I don't think there's any problem with the clay and all nano clay.
Mm-hmm.
Of course,
Okay.
plastics, as I told, right, as I told, if you drink I mean, 1 liter of no, that normal water from a plastic bottle, definitely nanoplastics will be there, and they are more dangerous, of course, because
Mm-hmm.
they are made up of plastics of polypropylene, polyethylene, and all those things. They are toxic.
Okay. So sorry for being a little probing on this. Why is it that in India, the nanotechnology is not being used very widely, in agriculture? What is stopping us from doing that?
Oh, no, we are using now, but
Mhm.
what is stopping is initially the cost of this nano materials is costlier. That's what other person asked about the startups in nanotechnology based this one. Right,
Right.
definitely, if more industries come, the cost becomes cheaper because Indian agriculture is mostly the poor farmers. They can't afford it. It's not an industry in India. That's another problem.
Okay.
It is not industry. Agriculture we don't consider it as an industry in India.
Mm-hmm. Mm-hmm.
It's livelihood of poor people. That's the reason we are not implementing. Okay.
Okay.
So if it is an
Okay.
industry, definitely over the period of time we can can grow more food. We are the people. We have vast land, but we are growing very less because
Right.
we are using traditional farming,
Right.
and they are not trained. That's the reason I told they use huge amount of pesticides.
Mm-hmm.
If you ask them to, spray 1 liter, they'll spray 5 liters.
So can we say that the adoption of nanotechnology in agriculture in India is still at a nascent stage? Can we
It's a
say that?
nascent
Huh?
stage, of
It
course.
is at a
It's the initial stage.
yeah.
Okay, but it has got huge potential.
Right.
Definitely, it has got huge potential. And
Okay.
the market, of course, if the big players come and they reduce the cost of these fertilizers and all,
Uh-huh.
definitely people start using this. Because you see, you are using one quintal of fertilizer per
Mm-hmm.
acre, but
Mm-hmm.
the same yield you get with 1 liter of nano fertilizer,
Right. Right.
and you are saving so much of
Okay.
waste. That
Okay.
SDG goal we can meet there.
Uh-huh.
Why
Like,
to waste?
like if I mean, do I have time to ask question or I should stop, sir? Organizers, please.
You can ask questions, sir. You can cross.
Okay,
No problem.
ma'am.
I'm there
So
to.
another query is when we started adopting green revolution, right? We started adopting for extra usage of fertilizers and pesticides, increase the productivity, and then eventually we found that they were not good for soil health. So, is there any kind of fear in adopting nanotechnology?
Yeah, there
And
is.
it's the
See,
detrimental effects are still not known to
so
human
many things. That's
kind,
what I told. The government regulations will be there,
right?
definitely. Yeah,
Okay,
because no technology is safe, right?
it's safe, right?
Everything.
Right.
Okay, what happened in Sri Lanka?
Right.
They went back to organic farming, and Chinese gave some soil. What
Right.
happened to them?
Right.
They are in debt.
Uh-huh. Okay, thank you so much, sir. Thank you
Thank you.
for
Thank you.
your patience, sir.
Yes, Mr. Akshay Maurya, if you would want to unmute yourself, you can ask, or else I can take up the question from the chat box. So I'll just read it for you. Yeah, it says, Mr. Akshay Maurya, he asked, like, given limited capital, how do we see agri-tech startups adopting and exploring the nanotech-based tools?
Yeah. So as I mentioned earlier, okay, you can right. You are talking about startups, right? So you can develop small sensors like moisture sensors and all. Definitely, we can sell because the farmers need those things, and even government. Nowadays, government is involving itself in many of the things. Right? There's a right subscription. Now, recently we have seen whole India. We can subscribe many journals. Okay, we don't have to subscribe individually. Government is subscribed. So similar things will come in future, I guess. Okay, they will help farmers to have the the sensor kits. They will distribute. Okay, the cost will be very less if government distributes it, right? And you can use them. Okay, and they will give it to small startups. They can produce and they can sell to the farmers. Those things may come. Okay, incubations and all. Definitely, it will help.
Hello.
Yeah.
Hello, sir. Good evening, sir. I'm Dr. Veena from VTU Vishesha Technological University. Sir, I have one question.
Yes, ma'am.
Sir, nowadays in agriculture, many people are saying drone technology is enhancing the fertilizer of the agriculture farming. We can at a time we can use both technology, drone as well as nanoscience particles and all. How it's going to help for the farmer, sir?
Yeah, drone technology already uses nanotechnology, madam. Drone itself has got sensors, nano sensors.
Oh, yes, sir. Sir, how it's efficiency, sir? It gives efficiency, sir.
Definitely, efficiency will increase, madam. I already in my talk I have mentioned that nanotechnology you don't require very, large amount. Very small amount is enough.
Sir, just I wanted to know what is the percentage of farmers in India they're using the technology for the growing for the crops.
No, I don't have that data with me, madam. Because I'm not
Oh,
a agriculture person. That's the problem. That's one.
okay,
I'm
okay,
I am a nanotechnology person. Right. I
okay,
have
sir. No, no, no.
this
In our
part
college
of
also we have nanotechnology department, sir. So I'm
yeah,
asking, sir.
yeah. Okay, ma'am.
Oh, thank you, sir. Thank you for
Right.
the information.
Data you can get it from the net, I guess. Nowadays
Yeah,
everything is
yeah.
available in.
Thank you, sir. Thank you so much for your response, sir.
Okay.
Thank you, ma'am. So there's another couple of questions if you would want,
Yeah,
if
yeah,
you're,
no problem, sir. You
yes.
can ask me
Yeah,
questions.
in the chat box it says, Ms. Khushbu Ashra says, what kinds of steps are being taken by the agri-tech startups and the government to make nanotechnology available to the users?
Nowadays, our government has taken initiative in nano fertilizers. That's what I can tell. Agriculture, the startups are coming up definitely. Many startups, I think, some not in probably I don't see anything in Belgium, but definitely they're coming. Startups are there.
Okay. There's another question by Mr. Vinayak Kulkarni. What are the ethical and safety considerations in deploying nanotechnology solutions in agriculture?
Yeah, definitely there are concerns. Okay, as I told, if you are using pesticides, nanotechnology. Okay, when you have to tell that they have to use PPE kit. Okay, the farmers cannot use with the bare hands or something. Nanotechnology, you have to use that the kit, because when you spray it, it may fall on you also, and it can cross even blood-brain barriers. Okay, that's another problem. That's the thing. That's what I'm telling. Okay, it's not that immediately acceptable. Okay, especially the pesticide thing. But fertilizers, the people are using. Right. So there are ethical issues. Okay, the government is taking the regulations. Okay, take care of the regulations and all. Okay, there will be some right solutions for that. Okay, definitely there are solutions. Okay, and you are not using huge amount. That's the reason you are not polluting the environment. But you have to take care. Okay, that you have to take that precautions. Yeah.
Yes, sir. So thank you so much. Last question. Can nano enhanced absorbents like foundry waste and dust be used for concrete?
Nano
Can nano enhanced absorbents like foundry waste and dust can it be used for concrete? It says.
concrete.
I think if the Mr. Nitin Deshpande, if you are there, you could just unmute yourself and you can elaborate on the question, please, if you are available.
Sir, good evening. This is Nitin Deshpande from KLS GIT, Department of
Ah,
Civil Engineering.
yeah, yeah. Tell
Sir,
me. Yeah, tell me.
the adsorbents that foundry waste and dust, can we use it in concrete for the variations? Because nowadays cement is one of the parameter that has to be reduced in concrete. So
Mhm.
can we use that foundry dust and foundry waste in form of nano composite material?
Definitely, people are using foundry, this one nanosilica and all. We can convert that into nanosilica and you can use it as adsorbent, not an issue.
Okay, okay.
And you can use it in that's soil. Of course, the sand that whatever you use, that no bake sand or whatever they use it for foundries. So
Yeah,
that
yes.
has to be right. The contaminants have to be removed first when you are
Okay,
using it in especially in construction or concrete purpose.
okay. So,
The
is it going
contaminants
to
are
give me
eliminated.
the
That's it.
strength of same of that of concrete, or is it going to have some reduction? Because usually we say that when we reduce any material, it is partially.
No, the thing is, it depends on the material itself,
Okay, sir.
right? Unless we do research on that, we cannot tell you whether it enhances or it reduces. But we can try. Okay,
Okay,
foundry waste definitely can do so many things. Okay,
okay.
no big sand will be there in that foundry waste, right?
Yes, sir.
So
Yes.
yeah, so we can use it, but what are the other things you should know? Okay, how they affect the quality of cement or quality of this one, that concrete.
Yes, sir. Sir, we have to even have microstructure properties, right?
Hmm.
Yes, sir.
Yeah.
Yes, sir. Thank you, sir. Thank you. Thank you.
Right.
Yes, sir. So thank you so much. Thank you so much for your wonderful session, sir.
No, if you could ask my question, which is there in the text box, can I come in?
Yeah, yes, sir, yes. Yes, sir, yes.
Actually, if you just see that, I just have wanted to know whether organic farming can it be imitated using nano, so that instead of using chemical fertilizers, can we move on to only such kind of fertilizers?
Yeah, sure, sir. Organic farming can be used. Because whatever the compost and all, we can make them as nano compost. Very good question, sir. May I know who is this? Yes.
Professor Deshpande from
Ah,
BTU.
sir. Okay, definitely, sir. It can be used because we can right composted this one. We can convert that into nano and we can use them. And in a small quantity, you can use because when you use nanotechnology, one advantage is the that uptake becomes faster. They can easily absorb the things, sir. The nutrients.
Thank you.
Yes. Thank you. Any other questions?
Yes, sir. Uh, so thank you so much for your wonderful session, sir.
Thank you,
Uh,
sir, Ajay, sir.
and we are indeed grateful to you and practically showing like how on online mode, like showing a cube and explaining the concept of nano. This is going very deep and going very down to the earth. So we are really thankful and explaining the entire concepts of nanotechnology and its alignment with the SDGs, all the five SDGs in alignment with the nanotechnology. I think it was a wonderful session. This is something out of the box and very unique session that we have had. So we are really grateful to you. So thank you so much. Thank you so much.
Thank you, sir. Thank you. Thank you so much. Thank you, everyone.
Thank you. Participants, please note, I think we have shared the feedback link, but I think there are some errors that we are just finding it from the participants. Give us some time, 5 minutes, give us some 5 minutes time. We'll just resolve and I'll just uh, put the feedback link back once again. So give us 2 minutes. And meanwhile, we'll just invite the next resource person for the day. You all can take 2 minutes break and we can start with the second session. So give us 2 minutes.